we've got Lindsay Lewis, who's the co-founder of Reflow, Sherry Handel, who's the executive director of the Additive Manufacturer Green Trade Association, and Samantha Snabes, who's the co-founder of Re3D. And I'll let everyone start with a brief introduction of yourselves. Lindsay, why don't you start?
Let's not have that. My mic is off as the first thing that happens. Hi, everybody. I am Lindsay Lewis. As Sarah said, I'm a co-founder at Reflow, which is a social enterprise turning discarded plastics into high-performance, source-traceable 3D printing materials. We enable creators to make circular products from sustainable materials, and together we can hopefully eliminate plastic pollution altogether. That's, I guess, a bit about me.
Yeah. What about you, Samantha?
Hi, I'm Samantha. I'm an Air Force reservist on the weekends, and during the week, I have the honor of serving as a co-founder and catalyst for Re3D. We are a South by Southwest Kickstarter baby that was spun out of Engineers Without Borders, NASA Johnson Space Center in 2013, with the vision to try to make 3D printing more accessible to users worldwide. We do that by focusing particularly on cost and scale. So we make a whole fleet of large, affordable industrial 3D printers. They start just under 9K US, about the size of a toilet, and now go as big as a shipping container. And our longer term vision was to further reduce that cost component by allowing you to not only use reflow filament, but also through the community support, we've modified our portfolio so you can print directly from pellets or flakes. So you can actually grind up a water bottle now. Here's some flake that you've seen, and use it to 3D print something at scale. So we're really excited now to be shipping those around the world in about 50 countries, and just learning alongside everyone else in an open source bootstrap model.
All right, and then Sherry.
Hi, I'm Sherry Handel, Executive Director of the Additive Manufacturer Green Trade Association, also known as the AMGTA. And the AMGTA was formed last year at FormNext, and I came on board as the trade group's first executive director last February. And we are a global and unaffiliated nonprofit organization open to any additive manufacturer or industry stakeholder that meets certain criteria relating to sustainability of production or process. So my role is to build and grow this new industry trade group worldwide and work with our members to take on the sustainability challenge in AM. So it's exciting to see sustainability in AM gaining a lot of momentum as companies are really striving to improve their eco footprints. And I'm proud to lead the AMGTA in our role as an industry resource to strategically position the AM industry to rise to the challenge of improving sustainability in AM.
Thank you, everyone. And my name is Sarah Osell. I'm the additive marketing manager at Dyndrite. I also started the Women in 3D Printing Seattle meetup back in 2018. I initially got into 3D printing because I was excited about the sustainability impacts from design for disassembly, new engineering techniques, the materials opportunities. That last presentation was awesome. And in this presentation today, we're going to be talking a lot about manufacturing waste, reducing distribution emissions, as well as product lifetime, which we'll also be touching on. So first, I wanted to go into a little introduction for what the circular economy is, for those of you who are new to the topic. So this is the butterfly diagram produced by the Ellen MacArthur Foundation in conjunction with Cradle to Cradle, which are two organizations which you definitely want to get connected with. It is a model for an industrial system that is restorative by design. So we have energy resources and material resources. Down the center here is our traditional linear economic model. We're now beginning to define users in this model, in addition to consumers, focusing on energy recovery and diverting waste, minimizing it. And all throughout this process, not just from the end users, which you'll see in this presentation, we can actually create these loops all throughout this, all the parts of the economy. And I wanted to emphasize that diagrams are tools for thinking. They're ways for us to build ideas and form opportunities. So wanted to start this off with a case study. So framing it in terms of additive. Samantha, your team had the opportunity to compete in a unique reverse pitch with the city of Austin. And we've mapped the supply chain that you developed here. Can you tell us a bit about how this event helped you form your business model of working directly with product manufacturers and sourcing waste?
And shout out to anyone on this panel or in the audience who has participated in a reverse pitch. So a reverse pitch is an opportunity for companies to identify excess waste or scrap they have within the community, and to allow people in the community to compete for unique ways to not just upcycle it, but hopefully create more value for it from it. And so Re3D's angle is and focus in the waste conversation was actually more about economic empowerment and creating new jobs. And we saw using waste, which everyone has, as a way to do that through large scale 3D printing. So this event that was held in the city of Austin, and the Austin reverse pitch, was really meaningful to us. And there was this amazing company. It's called HID Global. Fun fact: you may now see their logo everywhere. They make your driver's license, my military CAC card, and ID cards for many individuals all around the world. We probably all have one of their products in our wallet. When they're punching out your ID card, they have a lot of scrap, this trim, and they call it a skeleton. It's polycarbonate. It does have some dye on it. And so they dispose of up to 2,000 pounds every 10 days in the Austin landfills. So they were a really good candidate for reverse pitch. And our teammate, Mike, our chief of staff, pitched and won. And so that gave us $10,000. And what we decided to do with it is we installed a grinder at the Austin Habitat for Humanity Restore. So if you know of Habitat for Humanity, to make houses, they also have a thrift store that helps them bring in revenue from donated materials. And at the Restore, they have a lot of waste they have to dispose of, but their goal is to be green, right? And to create as much value as they can from the donated goods to benefit the community. So we did what we call circular pilot. It was during lockdown, the lowest foot traffic they've had in history to the store this summer for 8 weeks. But what we did is we took the polycarbonate that we ground up at the Restore, and we created objects such as, I think I have a vase here. It prints actually in a really pretty gray, the way that the dye combines. And we made a series of vases and other goods, as well as we took Greengate, who has a Reflow-like model where they're taking manufacturing waste to make filament in different forms, and also pellets we got from Holland that were medical waste through Cycler C. And we printed a series of goods that some of it would pair with actual waste at the Restore, such as like unreclaimed lumber, to make things like the bench you've seen here. And what we did is we put it on a silent auction with instructions in Spanish and English, and people over the course of 8 weeks could write down how much they would pay. So it was our opportunity to see what types of goods, at least in a thrift store, people would buy and how much they would pay for it. And what's crazy is we found there was a lot of demand for shelving and tables, which we hadn't anticipated, in addition to the chairs. And these goods were selling in a silent auction in a thrift store during a lockdown for $150 US each. So, I think that's just a first start at us looking at, one, how you make something that's strong and safe and can bear weight, but also, what people connect with, and how you can start to look at opportunities to create value from local waste, hopefully to benefit the community and also to create jobs. So a lot of work still has to be done. I can't wait to get your feedback and for you to tell us what we do next.
Yeah, and in the circular economy, actually, we're trying to stop using the word waste. It's not waste. Trying to think about everything as a material that we can use. Lindsay, I know you had a lot of experience doing this as well in your business. Could you tell us a bit about the challenges and considerations you've seen with recycled materials and sourcing these?
Yeah, for sure. Sort of like Samantha said, we use industrial waste as the input material. And I guess, like everybody knows, the quality of in a process, the quality of your output material is dependent on the quality of your input material. And finding quality inputs is really hard. Plastics recycling, particularly, we've discovered the sorting, because of course, plastics are like metals. There's like not one thing, there's a wide variety of things. And there's lots of complexities around that. But of course, that means there's opportunities, sort of like you said, Sarah. There's anyway, there's lots of opportunities to not think of waste, but to think of input materials. So we Reflow works with established recyclers as a source of our materials. Recycling is a really capital intensive industry, and we weren't in a position to do what those recycling companies do. We don't have the expertise, and they do. We have found it to be a really closed industry. So, and I think that stems from their business model, which is of course high volume, low cost. And they're also, like us, looking for a high quality input material. So when they find one, they hold on to it. They protect that. And that in some ways conflicts with our desire to have source traceable materials. So we've found a way to work with them to understand and audit as much of their supply chain as we can, while also performing tests on the materials that they provide to us to confirm what it is that they're telling us. So if we can source what we think is that material and compare the chemical properties to the materials that they give to us, are they similar or the same? Do the materials that they give to us appear to have been through some thermal cycles? So again, making sure, trust and verify, you want to be sure that we can in fact say to our customers, this material comes from food waste, for example, while at the same time protecting the sources of those recyclers so that we can maintain that positive relationship. And sort of along the same lines of the reverse pitch that Samantha was talking about, we've done some really interesting projects. They weren't targeted as reverse pitches, but worked with some organizations like KLM and Ace and Tate, where they came to us with kind of an interesting project to identify materials in their waste streams that are suitable for 3D printing. And then we worked with our recycling partners to develop a process to transform those into high performance 3D printing materials. And the materials that we came up with, some of them were totally expected, like PETG and PLA. Of course, those are well known in the 3D printing industry. They're or at least in the FDM part of the industry. Whereas we actually came across some interesting ones in our project with Ace and Tate in PMMA, which is less known in the industry, but we found to be actually really well suited for FDM printing. So then to close the loop, or at least add a little bit of a curl to the supply chain anyway, we're working with them to identify applications for them to use those 3D printing materials. So like in their retail design or in engineering tools that they're using or consumer products. So that's kind of a fun thing that we're working on from a product perspective. And just recently, actually, we're working on a project with an automotive company that approached us with the properties that they want in a material.
Oh, wow. And
then we're working to figure out what the recycled sources of those materials are so that we can then create the process to produce the material for them. So a really kind of a couple of different ways of coming at that plastic materials problem.
Yeah, and I think we're starting to see some common threads. So while historically maybe we would have been hesitant to be transparent about our materials, this is absolutely essential moving forward. We need strong collaborative relationships, and part of that is research and development. So Sherry, I know that's why the AMGTA was founded. Could you tell us a little bit more about Additive's potential to contribute to this problem and the reason why you exist?
Sure. Well, while the economic and technical superiority of additive manufacturing is well known within key industries, its environmental sustainability benefits are often less well understood because we don't have really good data and metrics. And so for this reason, the AMGTA was founded to promote the environmental benefits of AM over traditional manufacturing. And to really do that effectively, we need this research to substantiate the claims that we're making. So when our customers are asking us for transparency and validation, we have that available, and we serve as that conduit to provide that to our industry members as well as the industry at large and to the general public also. So there are definitely many positive environmental benefits of additive manufacturing when compared to traditional manufacturing processes, and most notably there's considerably less waste in AM. Although we have challenges in that area that we're all going to be speaking about or have spoken about. So existing research on sustainability in AM tends to focus either on waste, energy use, or machine emissions to manufacture a part. However, there's limited published research that considers life cycle assessment, which is a comparative study of the environmental impact a part or a product has throughout the stages of its life from cradle to grave. And this is based on that linear model we've been talking about, where it's take, make, use, pollute, right? We're working on a new model, which is the circular economy model, where that waste becomes an input as a new material. So it's very circular. And so life cycle assessment is kind of evaluating things based on the existing model of linear, but it's also applicable to the circular economy as well. You know, there's really, it's just in terms of it was structured at the time when there was strictly only a linear model. So again, I mentioned that there's these three silos in the research. There's waste, energy use, and also machine emissions. And there really hasn't been a full kind of holistic approach to really determining what it is we're doing from a sustainability perspective. And so we plan to address this lack of research by commissioning studies that include LCAs, which will analyze a part through each phase of its life, from raw material extraction, processing, manufacturing, transportation, assembly, use, and disposal. And LCA means to fully consider, again, what it takes to produce a metal AM part, for instance. So from the ore that's mined out of the ground, it's processed, refined to an AM powder through material through the gas atomization process, transported, and then, of course, the energy used to make a part, the emissions produced all along the way through the various stages, and there's many that I haven't even mentioned, to the part's eventual end of life, or perhaps repurposing, remaking would be the ultimate goal. So we want to understand that, and we want to be able to provide that data. So this year, the AMGTA is commissioning our first LCA project, which we're really excited about, working with a major U.S. university. And that product will compare an aerospace part produced by AM versus a traditional casting process to really be able to evaluate the differences between the two different manufacturing models.
Nice. Yeah. So because we're trying to transition from this linear model to a circular model, this involves a rebuilding of our infrastructure. So I wanted to touch on quickly before we head into how the audience can help. But what opportunities do you all see for the additive industry in the circular economy space? We've just talked about plastics, but I know we've got metals, biomaterials, really a world of opportunity out there. All right, who would like to start?
Sure, I'll go ahead. So as I mentioned in my introduction, my role is to build and grow the AMGTA globally and work with our member companies to take on the sustainability challenge in AM. So to really help the industry advance, we need that good, solid, reliable data on sustainability and metrics. So I work closely with our board of directors, which is comprised of our founding member companies, to help support this independent, rigorous, and ongoing sustainability research so we can provide that information to our membership to really advance sustainability. So last November, the AMGTA commissioned our first university research project, which was a literature-based systematic review of the environmental benefits of AM, of metal AM, I should say. And our research paper, entitled State of Knowledge of the Environmental Impacts of Metal Additive Manufacturing, was written by researchers at Delft University of Technology in the Netherlands and Dartmouth College here in the United States. And this report is available currently on our website, and it's available not just to members, but to anybody that's interested. And according to the researchers, the paper synthesizes existing academic literature comparing the environmental impacts of metal AM with conventional manufacturing methods and provides context, I should say, on the impacts of common metals and processing methods found in a materials database. So a lot of the data that exists in these life cycle assessment databases and for researchers comes from the different industries. So the challenge is that AM doesn't have any data really in the databases, so we have to build that data. And again, going back to the research of the paper, The goal was to summarize the current knowledge and identify areas where information is sparse, unclear, and much needed. So the key findings from this report include that while AM generally has a much higher carbon footprint per kilogram of material processed versus conventional manufacturing, when you look at the direct manufacturing process itself, the impacts are greatly dependent on geometry. So it's really key that it depends what you're doing. So a solid cube, of course, is going to be optimized to be manufactured by machining. But if you're looking for a hollow shell or lattice structure, that would be a lower impact to be produced by AM. So there were a lot of other findings from the study, but the report really identified the need for additional life cycle assessment studies to really quantify the environmental impacts. And to quote the researchers, more LCA studies are necessary to definitively compare metal AM to conventional manufacturing, especially direct comparisons of AM to machining, and especially for technologies such as binder jetting and direct energy depositions. These LCAs should ideally also include more of the product life cycle because that's been so sorely lacking. We definitely need that data. So another key takeaway is that no one would really expect metal AM to be a more sustainable way to manufacture basic metal parts, given the focused energy inherent in laser melting. But AM should definitely present a more sustainable course for manufacturing finished precision, key being precision components. And again, these findings really validate the need for more research. We need rigorous, ongoing, independent research. And we plan to continue to commission and publish these research findings to update the industry on what we're finding, but also on what our eco footprint is now and what we need to focus on to be more sustainable in the future.
Yeah, and thank you for sharing that. That's an awesome report. I will be sharing a link to several resources, and that includes the AMGTA website. I'd like to move now with Lyndsey and Samantha to talk about how our audience can contribute to building circular economy concepts within our companies and communities.
Yeah, for sure. I think there's all kinds of opportunities, both from a small startup space like Reflow, but also to work as an intrapreneur within a large company, to identify even small opportunities within that large organization, to look at different ways of sourcing things that you're needing, regardless of in essence what they are or what they're made of. Because by sort of like Sherry was saying, to look at that whole life cycle of whatever it is that you're looking for to source from within, again, whether you're a person within a large organization or like an individual entrepreneur, looking at that and making those changes. If we all do that, that makes a big impact, kind of when you add it all together.
Yeah, I definitely agree. Sherry makes some good points about data, which is important. So whether you're the entrepreneur in a large corporation, as Lyndsey pointed out, or you're on the startup or small business side trying to hustle for resources or develop those strategic partnerships, ultimately it's going to come down to that ROI and that data. I think it's important sometimes that we have to remind ourselves as well, but for the community and those on this call, and shout out to Closed Loop Plastics and Sharon, who I see here, while, it may look like sometimes we're doing the same thing, trash varies, demographics vary, needs vary, markets vary, and the need is so great. I think we'll all agree, and Lyndsey and I have had this conversation previously, but if we work our way out of a job because this need doesn't exist anymore, a way to sustainably and efficiently manufacture and to create a better society and to create value from excess material, then I think that's a good thing. So I think it's incumbent we view this as an ecosystem. We're overlapping and we're in this together. So there's lots of gaps on the hardware side. There's still a lot of gaps on the material side. And I think sometimes, there's been a lot of movement in terms of circular opportunities with AM and art, and the Dutch have really led that, and a lot of amazing pieces in Europe, and now we're seeing in California. But as we look out beyond just ones and twos or highly curated pieces that incite good conversation, as we look at truly scaling this, we want to look at, like as Lindsay pointed out, jigs and fixtures, the non-sexy stuff, or furniture that bears weight. And there's very little that's been done. And if, as the previous speaker pointed out, with architecture, we need science around what's load bearing, and maybe new standards in the way we test or qualify. Because for us to work with big brands at scale that have tons of waste, right now, Lindsay and I have the hard job in closed loop plastics of convincing some big brands and curated pilots to give us a small amount of their waste and take a big risk with those entrepreneurs. If we can come up with models to use a lot of it in a responsible way to create value and improve the local economy, that's awesome. But it's going to take a lot of time, and it's going to take a lot of women and ladies and gentlemen advocating for change and that risk. And if you're a strategic on this call, I think everyone on here would probably love to partner with you to explore what that looks like. And kudos to all of you that are creating consortia and models. So at Re3D, we say we dream big, print huge, but I think we'll all agree that we're all thinking about exploring a better society together.
Yeah, and I know when it comes, I think in our initial discussions, we talked about a culture of continuous quality and improvement. In my own experience, anytime you have the opportunity to make a purchasing decision, that's an opportunity to build some sustainability into your org. And it's always going to be small steps before they're big. But all right, we have to head to questions now. So the one with the top votes is from Zoe Kolbing. Since many of the resins are only biocompatible after proper curing, biocompatibility testing is crucial for medical products. Oh, this may have been from the previous panel. All right, so from LD Lazaro, for Samantha, how is it possible to recycle PLA through composting? Or how should we dispose our PLA scraps?
That's a tough one. It's funny, we talk a lot about being sustainable. And then as we were all making PPE in the last year, we made a lot of single-use plastic that got thrown away. My heart kind of hurt. Shamelessly, I did bury some PLA in Santiago when we started in Chile in 2013 in a park. I'm pretty sure it's still sitting there. I learned that for it really to biodegrade, it takes a lot of pressure and time. So right now, we definitely encourage you to look at, we're not the only individuals in pellet extrusion. There's a couple of great solutions, 3D Evo, Precious Plastics, Fill Extruder, that allow you to take your waste and turn it, your excess PLA and grind it up and turn it into filament. The research right now, again, the research is lagging. It looks like you can get a good 2 to 3 shakes out of the melting and extrusion steps. Lindsay might know more because she manufactures filament. We're hearing now maybe you can get 5 to 7. What some people are doing to increase degradation and to mitigate that is they're adding in certain natural fibers. So that's another solution. You can put waste with your waste. But right now that seems like the best fit for reusing plastic. We also grind up PLA. We got an annex to our shop and run it through Gigabyte X. So we print directly from the regrind. But right now, 3D printing and repurposing the print is probably the best way to go about it. It makes it really difficult, though, when you print large objects that don't fit into a grinder or granulator, and you got to whack them with a hammer to stick them back in and grind them up.
Yeah.
Go ahead.
Sorry, just to kind of add to what Samantha was saying, we do produce recycled PLA from food waste in the Benelux area. So it does exist, and it is possible to get at least one more cycle out of it. As far as the disposing of PLA scraps, it is a lot harder because it's not something, at least for us, that traditional recyclers will accept as an input material because of the variety of colors and anyway, the chemical makeup. So it's something that we have been thinking about on a really small scale to take unloved prints, we love to call them, and figure out a way to put them back into our process. But that's still a work in progress and likely a long way away, at least for us.
Yeah, this is definitely an area where the industry needs more research. All right, so next question from So Young Han. Hi, I'm directing a maker innovation labs in USM. Many regional makers are seeking a method to make our AM facilities more sustainable, but not sure where to start. Any suggestions?
Yeah, so a quick one I would say is, reverse pitch is a movement that's starting. So definitely check with your local municipality to see if they have anything similar. A lot of the early Gigabyte X sales, as we've been selling them in beta, the machine that can print from pellets or regrind, have been to communities where they're forming these really interesting networks between a university, maybe a big strategic, so a business, and a government agency, as well as an academic school where there's a first mover, and they're exploring using waste in different ways and collecting that data, as Sherry pointed out. And we're seeing that all over in a lot of non-traditional markets that we would sell to. So you may want to Google sustainability, email Sherry and see if she's got a lead, or Lindsay or I saw Carolina Rojas on here from Panama. We might be able to give you a tip of people thinking about this in your area, so you can block together, and sometimes there's grant funding to work with your makerspace to start to explore what would make sense locally for you.
Yeah, and I would always also comment on energy resources. If the university potentially has a program like this, try and get solar. There's also simply trying to reduce the print errors. Like we just talked about, issues with recycling filament and all of the unloved prints. Work on, if someone is submitting something that might potentially fail, try and catch that before it fails. All right, next question is from Mariah Mehran. At my company, Mava, we're exploring turning recycled plastic mixed with concrete to be used in construction 3D printing. Any recommendations on partners or material scientists to join our team? This housing is going to be big in the future. Samantha, what do you think?
Yeah, there's a lot of people in the cement side of things, lightweight concrete, sometimes is what they call it, around the world. We received a number of emails over the years. We focus more on polymers, but if you want to, I'll put my email in here, and our teammate Charlotte, who leads our engagement efforts, I saw is in the chat too. We can send you a list if that's helpful as a place to get started. But there's a number of groups in the space. I would always recommend maybe reaching out to someone that's local, because you're gonna be learning a lot together, and the closer you are to form those connections and to evaluate the output real time, I think the better.
Yeah, I also know our industry, we have some technical fellows that are just brilliant people. So on LinkedIn, if you can try and search for additive manufacturing technical fellows, they usually reach out. Okay, so for Lindsay, the recycled filament you make can be disposed in a compost bin. Oh, can it be disposed in a compost bin?
Yeah, our PLA, you can treat it like the food waste that is also PLA. So kind of like Samantha said, you can't throw it in the ground. It's not going to magically, because it's been through the reflow process, be able to decompose that way. But you can put it through a industrial composting system, and it will break down.
Awesome. From Izzy de la Guardia, one of the biggest difficulties in circular economy is reclaiming waste for reuse. What are the most promising models for reclaim that you have seen, and what will make reclaiming successful?
Lindsay and I might differ in the approach here. Being a bootstrap social enterprise manufacturing hardware in the USA. We've had to be pretty scrappy. So for us, we've prioritized based on what we could get grant funding for. And a conversation that seems to come up a lot is around water bottles. What's nice about that is it is a consumer plastic, but there's usually a lot of it, particularly even in disaster response and humanitarian crises, as well as anywhere else in the world. And so because it's clean and typed, generally the formulations we found have differed, as well as the thickness of the water bottle, which can be a pain in the booty sometimes to work with. But we've prioritized research around that just because people get it. But we have found the biggest opportunities actually not with consumer waste, it's with manufacturing, scrap and trim. So because we have an office in Puerto Rico, we put a lot of weight personally around like pharmaceutical companies. Again, kind of looking at scrap and trim that's very well defined, controlled. We know there's a lot of it. And then we especially are committed to, like, I'm talking with Carolina about the Gunayala, Sarapanama, or looking at island nations to include New Zealand, which just got a Gigabyte X yesterday, Australia, Japan, anywhere where landfills are filling up and there's not a lot of land, and there's waste, and then targeting those corporations that might be big contributors.
All right, this is probably quick. Do you know of any companies or resources in Canada related to reverse pitch or upcycling?
I don't off the top of my head, but feel free to drop me a line and I'm happy to do a little bit of research. I would look up Cirque Design. It's a small company in Montreal that's actually using Reflow as an input to his manufacturing of home goods. It's CRIC. Totally recommend looking up Guy. He's fantastic.
Awesome. And yeah, and anyone feel free to connect with us on LinkedIn. Send a note though, so we know like where you're coming from. All right. So another question from Michael at 3DPI. I'm thinking a little bit about the new administration's Made in America executive order here, but in general, what are your thoughts on on-demand and distributed manufacturing? How can, the question cut off. So thoughts on on-demand or distributed manufacturing?
I think that there's I am not in the US, I'm in Canada, and Reflow's based in Amsterdam. So maybe I'm not the best person to be speaking to this, but I do think that there's some real interesting things happening around on-demand manufacturing, specifically with additive manufacturing, because they go really well together. Actually, now that as I'm speaking, I'm wondering if Samantha might be a better better person to chat about this, or Sherry.
I do have a comment. Yeah. Well, if you're not familiar with America Makes, check them out. They're in Youngstown, Ohio, and they are a nonprofit trade organization based in the United States, strictly looking at how they can advance Made in America, and they're focused solely on additive manufacturing, which is terrific because that is exactly what they're doing currently, and they've been doing it for quite a while. So they do have a lot of programs and events, as well as webinars heavily now due to the virtual nature of business. So you can check them out at the America Makes website.
They have a table here at the event as well.
Yes.
So maybe after this talk, you can jump down. I think it's like floor 1 or 2. I tried to bomb it this morning. Yeah, but a great consortia. And then if you decide to join them, I hope they're okay with us marketing this. There are opportunities to work for credit to get the membership, because I know sometimes like membership and consortiums can be cost prohibitive if you're getting started. So they do have a model to be more inclusive that way. In terms of distributed manufacturing versus on-demand manufacturing, I think Sherry really hit the nail on the head. As you kind of dig under the hood, you really have to drill down to see, what is the best solution for your organization and your waste stream. Full disclosure, besides the HID Global plastic here in Austin that we ground up and printed with, the RPIT pellets we were using to refine the screw design that we use for Gigabyte X has been benchmarked against pellets made from 100% medical waste that came from Holland. So they were flown over for us to do that benchmarking. So, ideally you want to close the loop as much as possible, but there may be times or instances where distributed manufacturing is still a better fit. And until you do that LCA, you might not know.
Yeah, and a lot of these processes are pretty hands-on right now. But I would like to see moving forward with the LCAs an understanding of, so when you're producing a model and you're planning to have certain customers in certain places, maybe it's best to send the file to another supplier to reduce those emissions. Maybe that localization of that production reduces the total sustainability of the part, or increases the sustainability of the part. All right. So Reflow, for Reflow, what tests do you perform to understand the thermal history?
The one at least that we do is the DSC test. I had to double check what it stands for, but the differential scanning calorimetry is what our main kind of testing, at least for that thermal history.
Okay. Moving on that topic, from Julia Goldstein, is material testing a big issue? Do companies worry that repurposed materials, especially plastics, won't have the quality that manufacturers need? You're both nodding yes.
Yeah, that I would say the fact that, or the myth that recycled materials can't have the same quality and the same properties that a virgin material is rampant. It's everywhere. And I think that there's a reason that it exists, because historically it's like sometimes been the case and you didn't always know what you were going to get. But we've made, I think, as I don't know, obviously that's something that's important to Reflow, but it's also important to all of the manufacturers in this space. Like, that's super important to all of us to dispel that myth. And we're working hard to prove that materials that are made from sustainable sources can in fact also be super high quality.
Yeah, ARPED is surprisingly strong when you make objects with it compared to PET and super accessible. Yet, I can't speak for Reflow, but at Re3D, nobody is a material scientist and nobody has a PhD in chemistry. But we're basically, when you get down to waste extrusion, you're doing chemistry real time. And I was thrilled to see, and I'll be bombing their table as well as all of y'all. ASTM was here, but we now have 2 test stands, an Admet and an Instron in-house, and more and more people in our team are getting cross-trained on how to use that to make coupons. And one of the services we found, even when we started selling Gigabyte X, and Reflow has probably encountered this as well, is these bigger brands that maybe are customers that could see a lot of upside in this conversation need data, because quality and consistency is really important to them. And they want to know that their material is viable before they invest too many resources. So we now offer materials testing in different tiers as a service. So the first tier is, can it make what we call a little poop? Sorry, Helen. That's what we call it. And so we see if we can make a little poop with Gigabyte X. Looks like the poop emoji. And we're like, well, it can extrude. Or if it can't, we figure out maybe what needs to be adjusted. And then we have another tier where, we might make a test coupon and do some basic testing on that. And then a third tier where we might print a print that the client might be interested in and submit that for testing. But really that testing goes hand in hand as we look at standards, as we look at creating the databases that Sherry outlined, and truly proving that this has scalable potential.
All right. Last slightly controversial question, really quick. People have mentioned sustainability is dead. Do you think regenerative design could be a future for AM? Have you seen any projects in this direction?
Regarding sustainability being dead, well, how would you address the fact that pretty much every major university in the world has a sustainability program on corporate social responsibility, and environmental investing is becoming very important across the country and around the world. So I don't agree with that statement at all, and I wonder who actually said it because it doesn't have any validity in anything that I'm seeing, and I see my fellow panelists are smiling as well, so I'm interested in their remarks.
Really quick, I think we're coming up on time. Oh, Lindsay?
I was going to say, I don't have much to add beyond what Sherry said. I think that it's, okay. Yeah, I think she hit it out of the park.
I would recommend checking out Neri Oxman's work. She's kind of like the founder of material ecology. It's a whole new field. It's going to turn that statement around. Kristen, I think our panel ends at 10:45.
Yeah, we're at the end here. We're going to be breaking now for an hour.